Factors influencing risk: voluntary and involuntary risk. Voluntary means when the person is willingly taking up the risk, and involuntary means a process takes place and the risk comes automatically with it. Short term and long term consequences. Risk can have both short term and long term consequences. Delayed and immediate risk. Similarly, when a process takes place, the risk can be either immediate or delayed. Then the expected probability of risk, reversible effects. Any design, if it's designed and if there is a safety problem, can the problem be reversed? Then the threshold levels of risk, how much risk can be withstood. Then the risk assessment, a combined effort of identifying and analyzing potential events that may negatively impact individuals, assets, or environments. That is called risk assessment. And the steps in risk assessment are identifying hazards, decide who will be harmed, assess the risk and action to be taken, make record of findings, review of risk management, etc. Now, what are the uncertainties in risk assessment? Restricted access to knowledge, uncertain behavior of materials, uncertain and varying behavior of user environments, the misuse of material or products remaining untracked, newer applications of obsolete technology remaining unpublished, substitution of newer materials whose behavior are not disclosed, the unexpected and unintended outcomes of product or project. Then we have risk analysis. Risk analysis can be done in 4 ways: scenario analysis, failure and effect analysis, fault tree analysis, and event tree analysis. In scenario analysis, test starts from a given event and then studies the different consequences that might develop from it. Then the failure and effect analysis. It systematically examines the failure modes and the effects corresponding to all these modes. Then we have fault tree analysis, wherein we propose or provide a system with a failure, and then we analyze the result. Event tree analysis is just the opposite of fault tree analysis, and it is useful in identifying a potentially hazardous situation in the plant. Then we have the risk-benefit analysis. It is a technique similar to cost-benefit analysis used to analyze the risk in a project and to determine whether the project should be carried out or not. That is, if we are proposing a particular project, then there will be a committee to check the risk related to it. And we will analyze the risk, and then they will give an opinion regarding whether the project can be continued or whether it should be stopped. It answers the following questions: what are the benefits of the project? Is the project worth the risk taken? Do the benefits outweigh the risk? The major reasons for analysis of risk benefit are to know risks and benefits and weigh them each, to decide on design's advisability of product, and to suggest and modify the design so that the risks are eliminated or at least reduced. For example, we can consider our mobile phones. We all know that mobile phones deal with radioaction, and this radioactivity is not good for our body. So still we use it because of the advantages or the facilities it provides. So here the risks and the benefits are weighed and it is compared. So we go to a conclusion that mobile phones are a necessity and we follow up with it. Then we have personal risk and public risk. If sufficient information is given to a person, then he can decide whether to take a risk or not. That is, it can be a voluntary risk or an involuntary risk. It is assessed by assessing the voluntary activities, assessing the degree of occupational hazard and its effect on health. Now then we have the public risk. Risk of being encountered by a large number of people. Now to assess the risk, the loss on assets and correction costs are estimated. How can we reduce this risk? Techniques adopted to reduce risk. Application of inherent safety concepts in design. and example is given. LPG is provided with frame to protect valve while handling. Then we have the redundancy principle in design. Then periodical monitoring or inspection and testing of safety system to ensure reliability. Issue of operational manual so that the personnel handling it can use it. Development of well designed emergency evacuation plan and drills. Then we have safe exit. In the study of safety, the safe exit principles are recommended. The conditions referred to as safe exit are: the product, even if it fails, it should fail safely. The product, when it fails, can be abandoned safely without causing any environmental issues. The user can safely escape from the product. So, when we are designing a product, it should be done in such a way that even if this product fails, it should fail in a safe way, at least safe as possible, so that a safe exit is possible for the public.